We are going to look at some of the key points within Get More Math on quadratics. So to remind you, I have this parabola here. These critical points are all going to be extremely important in this unit. So to throw in just one or two more vocabulary words here, this parabola is symmetrical. If I were to draw a vertical line down through the vertex and folded this parabola on that line, it would create two symmetrical halves. This line is known as the axis of symmetry. Okay, so that's a vertical line. One of the things that you have to do is write the equation of the axis of symmetry. Since it's a vertical line, it's going to be in the form of x equals some number. So let's say hypothetically that this vertex is at the point 210. Now, maybe it's not, but that could work here. So this equation for the axis of symmetry would be x equals 2 because it would go through 2 right there on the x-axis. The other thing I want to talk about is the domain and the range of a parabola. Well, the domain is going to be all real numbers because parabolas are going to get infinitely wider. So they're going to go infinitely in both directions. So I can say all real numbers, and right there I have the symbol for all real numbers. And as far as the range, well, the range of a parabola is going to change. Here the parabola goes infinitely downward on this parabola on the right part of your screen. So this range is going to be all y values, and since it's getting smaller, that are less than or equal to the highest point. Well, again, the highest point occurs at that vertex. Y is less than or equal to 10. Now, if your parabola opened upward, okay, and let's say that the vertex on this parabola happened to be, just making something up, -3, 4, this range would be all the y values greater than or equal to 4 because it goes infinitely upward. Okay, so let's practice using GMM here to find some of these key points. So the vertex here sits right on the x-axis. This vertex is the ordered pair -2, 0. The y-intercept is where a graph crosses the y-axis. So that's the ordered pair 0, 4. The x-intercepts, well, sometimes there's going to be 2. It's possible that there are none. If there would be no x-intercepts, that would be because maybe the parabola is up here, never touches the x-axis, or if it's down here. Okay, but this does have an x-intercept, and it is at the point -2, 0. The range goes infinitely upwards, so this is y is greater than or equal to, the lowest it goes is 0 because that ordered pair is -2, 0. So all values bigger than or equal to 0. The axis of symmetry is always a vertical line. It is x equals -2 in this scenario. All right, I got this one right. I'm going to do one more here. The vertex of this one is, let's see, battery's about to die. This vertex is 3, -4, point where the parabola changes direction. The y-intercept is where it crosses the y-axis. That's here. That would be the ordered pair 0, 5. My zeros. Now, a 0 is a synonym for an x-intercept, but kind of a important note here. If you are asked for the x-intercepts, you can enter ordered pairs. So the ordered pairs for where this particular one crosses the x-axis would be 1, 0, but it would also cross at 5, 0 on the x-axis. However, a synonym is the word zeros, but you format it a little bit different. It's where x equals 0. So here we say x is equal to +1 and x is equal to 5. So notice the different notation you have to use depending on the vocabulary. All right, so I'm going to put my 0 is x equals 1. I just separated them with a comma, and x equals 5. My range, again, is going upward, so it's all the y values that are greater than or equal to, the lowest one here is -4. The axis of symmetry is a vertical line, so it's x equals 3. All right, I want you to practice your vocabulary now.